Yes, sir.
Okay, shall we
Clear
start?
light visible. Yes.
Okay, last time we were discussing about the recovery of the fermentation product, and in this recovery we were discussing about the solvent extraction technique or liquid extraction. And in the solvent extraction or liquid extraction, we have seen the one of the most efficient technique, that is called as a Podbilan countercurrent solvent extraction system, which is a countercurrent solvent extraction system. Okay, the next question arises: what happens the solvent which is used, that solvent we have to remove? So in our syllabus, what happens, sometimes it is mentioned as a distillation. Distillation असं म्हटलेलं आहे किंवा solvent recovery. I hope that all of you might be heard this word distillation. So what happens in the solvent recovery, which is carried out by distillation, and distillation is a technique, method, procedure which is based on the principle of there is a difference in the boiling point of the various liquids, boiling point of the various solvents. So the solvents which having low boiling points, so at the low temperature they will be vaporized, and when they come in contact with the cool water, they will get condensate. And later on, the solvents which are having higher boiling point, so they will vaporization of those solvents will occur later on, and when they come in contact with the cool water, there is a condensation and separation. So what happens, all of you remember well, what happens when we have used the solvent for the extraction of a desirable fermentation product. Solvent which is used for extraction of desirable fermentation product, that solvent we have to separate, that solvent we have to recover, because the fermentation economics does not allows us to leave the solvent as it is. Therefore it is necessary, therefore it is essential to recover the solvent. And the technique which is used for recovery of the solvent, the technique is called as a distillation. So major atom of equipment in the extraction process is the solvent recovery plant, which is usually a distillation plant, a distillation unit, a distillation technique, a distillation method, or a distillation procedure. So what happens in some process, it is not normally essential to remove all the raffinate from the solvent, because it may be recycled throughout the system. So what happens in some processes, it is more difficult to remove all the solvent from the raffinate because of the value of the solvent and problems of the contamination of the product. So when you go through the scientific literature, you will find that distillation may be achieved in three stages, or three steps are there. The first step is the evaporation, that is removal of the solvent as a vapor from the solution. Distillation may be achieved, carried out in three stages. The first step or stage is the evaporation, that is the removal of the solvent as a vapor from the solution. Then the next one is the vapor liquid separation in a column, to separate the lower boiling and more volatile component from other less volatile components. And the third one is the condensation of the vapor to recover the more volatile solvent fraction. Solvent fraction. So evaporation is the removal of the solvent from the solution by application of the heat to the solution. In the last slide, I have told you evaporation. So evaporation is the removal of the solvent from the solution by the application of the heat to the solution. The solution. There are wide range of evaporators available. Some are operated on batch basis, some are operated on continuous basis. So as far as this batch distillation process is considered, So here you will find the diagram of batch distillation process. So in this batch distillation evaporation system or process, the mixture which is to be distilled, that mixture is added or kept here. Then heating outlet, this is heating jacket, heating inlet, and this is the evaporator. So what happens when we apply the heat or temperature? This is the distillation column, or this is the tray or perforated plate. And when we apply the temperature or heat to this mixture which is to be separated, so just now I have told you people, in this mixture the different solvents will be there, and those solvents will have a different boiling point, and on the basis of boiling point they will be separated from this what you can say, this tray or perforated plate evaporator. So what happens when this vapor of these various solvents come in contact with the, this is the cooling water outlet, and this is the condenser. This is the condenser where condensation of the solvent take place. So this is the some of the condenser which is a reflux or which goes back to this evaporator, and this is the first fraction, second fraction, and n fraction. So the first fraction will be more refined. The second fraction again more this next solvent which is having the temperature, elevated temperature, or which gets evaporated at a rather higher temperature, and these are the nth fractions. So all of you remember well what you have to remember well. We were discussing about the recovery of the product. So distillation is one of the technique of recovery of the product, which is carried out by either batch distillation or continuous distillation. So here you will find again the same. Just now I have given you people the explanation. That is, in batch distillation, the vapor from evaporator passes up the column and is condensed in the cool surfaces of the series of pipes filled with a suitable coolant, and part of condensate will be returned as the reflex for the counter current contact with the rising vapor in the column. The distillation is continued until a satisfactory recovery of the lower boiling, more volatile component has been accomplished. Samujay? Then in case of continuous distillation, which is initially began in a similar way as with batch distillation, but no condensate is initially withdrawn. There is a total reflux of the condensate until ideal operating conditions have been established throughout the column. At this stage, the liquid feed is fed into the column at an intermediate level. The more volatile components move upwards as vapor is condensed, followed by partial reflux of condensate. Meanwhile, the less volatile fractions move down to the uh, column to the evaporator, or this is called as a reboiler. At this stage, part of the bottom fraction is continuously withdrawn and part is recycled to the column. Here you will find this is the diagram of, this is the diagrammatic depiction of continuous evaporator, continuous distillation system of evaporator. So here evaporator or reboiler heating is carried out, and from this bottom product which is the raffinate, you can say this is the evaporator vapor. It goes through this distillation column from vapor. Again, this is the cooling water, condensate, distillate. So continuous fashion, in a continuous fashion, the what you can say, this continuous evaporator works out. Like a perforated plates असतात आणि rectifying section is there, inlet for mixture, then stripping section वगैरे वगैरे सगळे त्याचे parts असतात. So all of you remember well that is distillation is carried out by batch distillation and by continuous distillation. This is the equipment, or this is the apparatus equipment for continuous distillation process. The plate or tray column consists of number of distinct chambers which are shown in the diagram, which are separated by perforated plates or trays. The rising vapor bubbles through the liquid which is flowing across each plate and is dispersed into the liquid from perforations or from bubble caps. The liquid flows across the plates and reaches the evaporation by series. Okay. Shraddha Shelar, are you there? Shraddha, Manasi Guru, Manasi Guru,
Yes, sir.
are you there?
हाँ सर.
बर मी आता काय कोणतं टेक्निक सांगितलं रिकव्हरी मधलं? Which technique I have told you people just now, Manasi, from recovery unit? Are you there? You were there, Manasi, or you were not there? Mrudula Kumbar, Snehal Patil, स्नेहल पाटील. कोणतं युनिट सांगितलं मी आता? कोणतं टेक्निक सांगितलं? सचिता, okay, the next technique as per your syllabus, precipitation. So precipitation is a formation of insoluble complex or salts by adding a suitable organic solvent or by adding a compound. It is possible to obtain some products from the broth by precipitation technique. Precipitation हे नाव ऐकले का तुम्ही बाळांनो? मृदुला कुंभार, precipitation. Yes. Precipitation technique ऐकलंय का नाव? So this precipitation technique, precipitation is nothing but formation of insoluble complex or salts by adding suitable organic solvent, suitable substance, suitable compound, or by adding a suitable compound. It is possible to obtain some products from the broth. We can carry out direct precipitation of those products. For example, in production of terramycin, a suitable long chain quaternary ammonium compound is added to the filtered broth. For example, terramycin is an antibiotic, and from the harvested broth for direct precipitation of terramycin, a precipitant, a suitable precipitant, a long chain quaternary ammonium compound is added to the filtered broth, which results into the formation of an insoluble precipitate from which the terramycin can be recovered. So apart from terramycin, here they are given one more example, that is dextran sugars can be precipitated by organic solvent methanol. Then calcium hydroxide lime is used for precipitation of citric acid as a calcium salt of citric acid. तर इथं प्रिसिपिटेशन मध्ये पहिलं उदाहरण त्यांनी दिलेलं आहे टेरामायसिनचं, आणि टेरामायसिन साठी लॉंग चेन क्वाटर्नरी अमोनियम कंपाउंड, dextran with sugar which is precipitated by organic solvent methanol. Then calcium hydroxide, that is the lime, is used for precipitation of citric acid as a calcium salt of citric acid. I hope that you might have been heard the word protein precipitation by the commonest salt, that is ammonium or sodium sulfate. The proteins which are present in the harvested broth, those proteins can be separated, precipitated by the one of the most commonly used salt, that is the sodium or ammonium sulfate, ammonium or sodium sulfate, as well as by use of high molecular weight polymers, that is polyethylene glycols, polymers, glycols. Tanvi Kale, are you there? Tanvi Kale, yes.
Yes, sir.
Yes, very good, very good. So just now I have told you people one more technique, that is a precipitation. And prior to that precipitation, I have told you people the technique, what we call this is the distillation. And last technique, second last technique in your syllabus, just now I have shown you people my PPT or my slide. Tanvi, in that slide, you might have been seen chromatography was written. So chromatography technique is used for isolation purification of the desirable fermentation product. So Tanvi, I would like to ask you the question. Will you able to tell me something about chromatography, how it is useful for recovery of the fermentation product? Tanvi, Kale. Yes, you Tanvi. Yes, Tanvi.
Yes, sir.
हा सांगू शकते का क्रोमॅटोग्राफी बद्दल काय माहिती? येस तन्वी. माहिती आहे का नाही तन्वी? सोनाली निकम. हा तन्वी बोल. बोल तन्वी.
The chromatography is used for separation of mixture.
Separation of.
Mixture of components.
Hmm. So last year we might have been used this chromatography technique for to some extent, not on large scale, but it is used for separation of various sugars, various amino acids, various organic acids. So chromatography technique, we can use it for the recovery purpose. Chromatography technique, we can use it for recovery of the product. So when you go through the scientific literature, you will find that as far as chromatography is considered, there are many fermentation processes, chromatographic techniques are used to isolate and purify relatively low concentrations of metabolic products. Metabolic. Depending on the mechanism by which the solutes may be differentially held in a column, the techniques can be grouped as follows. Say, for example, adsorption chromatography, ion exchange chromatography is there, gel filtration chromatography is there, affinity chromatography is there. So of these various techniques, we would like to see some of the representative techniques. So chromatography techniques are used in final purification of number of fermentation product. Chromatography technique is used in the final purification of number of products. So first we will see the adsorption chromatography, meaning itself indicates that desirable fermentation product, we have to adsorb it on a suitable adsorbent. We have to adsorb it on a suitable adsorbent. So what happens in adsorption chromatography involves binding of the solute to the solid phase primarily by weak van der Waals forces, van der Waals forces or van der Waals forces earlier we used to call. The materials used for this purpose to pack the column include uh, uh, inorganic adsorbents like active carbon, aluminum oxide, aluminum hydroxide, magnesium oxide, silica gel, and organic macroporous resin. So just now I have told you people for the separation of some of the desirable fermentation products, adsorption chromatography is used, meaning itself indicates that you have to adsorb the fermentation product by using adsorbents, that is active carbon, aluminum oxide, aluminum hydroxide, magnesium oxide, silica gel, and other organic microporous resins. तर ते sticky substances resins use करायचे. So in case of dihydrostreptomycin can be extracted. Dihydrostreptomycin can be extracted from filtrates using activated charcoal column. It is then eluted with methanolic hydrochloric acid and then purified in further stages. So here they have been given example of isolation, purification, or recovery of the dihydrostreptomycin by use of this chromatography technique. By use of this chromatography technique. So here active carbon may be used to remove the pigments to clarify the broth. So this active carbon may be used for removal of certain pigments to clarify the broth. Whereas penicillin containing solvents may be treated with 0.25 to 0.50% active carbon to remove pigments and other impurities. Pigments and other impurities. Then one more type of the chromatography, you might have been heard the name ion exchange chromatography, meaning itself indicates that there is a rule of nature that is positively charged substances gets attracted towards negatively, whereas anodic substances gets attracted towards the cathodic substances, and this rule of nature is exploited here in case of ion exchange. So ion exchange can be defined. Ion exchange can be defined as the reversible exchange of. Ion exchange can be defined as the reversible exchange of ions between a liquid phase and a solid phase, which is not accompanied by any radical change in the solid structure. Ion exchange can be defined as a reversible exchange of ions between a liquid phase and a solid phase, which is not accompanied by any radical change in the solid structure. So, in case of ion exchange chromatography, either cationic exchange resins or ionic exchange resins are used. Here they will mention cationic ion exchange resins normally contain a sulfuric acid, a carboxylic acid, or phosphoric acid active group. Cationic ion exchange resin मध्ये काय काय असते? Normally contains sulfonic acid, carboxylic acid, or phosphonic acid active group. Phosphonic acid active group. Whereas in case of anionic ion exchange resins normally contain a secondary amine, quaternary amine, or quaternary ammonium active group. The appropriate resin for a particular purpose will depend upon the various factors such as bead size, pore size, diffusion rate, resin capacity, range of reactive groups, and the life of the resin before replacement. Life of the resin before replacement. So here you will find weak acid cationic exchange resin can be used in the isolation and purification of streptomycin, neomycin, and similar antibiotics. So in the recovery of antibiotic streptomycin, the harvested filtrate is fed onto a column of weak acid cationic resin such as amberlite IRC50, which is in the sodium form, The streptomycin is adsorbed onto the column and the sodium ions are displaced displays. The resin bed is then rinsed with water and eluted with dilute hydrochloric acid to release the bound streptomycin. इथे जे लास्ट स्लाइड मध्ये इथे जे काय बाउंड स्ट्रेप्टोमायसिन आहे ते बाउंड स्ट्रेप्टोमायसिन रिलीज करण्यासाठी हायड्रोक्लोरिक ऍसिड वापरल्यानंतर हे जे काय रेझिन सेपरेट होत असतं आणि स्ट्रेप्टोमायसिन फ्री स्ट्रेप्टोमायसिन मिळत असतं आपल्याला. The resin column is again regenerated to the sodium form by passing an adequate volume of NaOH for reuse. Reuse करण्यासाठी परत त्याच्यामध्ये काय टाकायचं आहे NaOH टाकलं की परत इथं आपणाला हा रेझिन मिळत असतं RCOO रेझिन मिळत असतं आणि ते रेझिन परत आपण वापरू शकतो. हे रेझिन आपण वापरू शकतो. तर आयन एक्सचेंज रेझिन मध्ये काय करायचंय आपल्याला either cationic ion exchange resin or anionic ion exchange resin we have to use it and opposite we have to use it and the harvested broth should have the opposite charges you can say on this as opposite charges याच्या काय म्हणायचं आहे जे काही रेझिन आहे त्या रेझिनचा चार्ज आणि तुमचा याचा हार्वेस्टेड ब्रॉथ मधले जे काय फर्मेंटेड प्रॉडक्ट आहे त्याचे वेगवेगळे चार्जेस असल्यामुळे त्याचं काय होणार आहे सेपरेशन होणार आहे. The next one is the affinity chromatography. Affinity chromatography is a potentially separation technique with many applications since it is possible to use for separation and purification of most biological molecules on the basis of their function or chemical structure. So what happens in here in case of affinity chromatography technique, which is highly depends upon or which is highly specific interactions between pairs of biological materials. As all of you are aware, there is always proper affinity for every enzyme and substrates. They are very specific. Every enzyme and substrate, they are very specific. By exploiting this property in affinity chromatography, it is possible to separate the either enzyme or substrate because there is a very high affinity for certain enzymes to certain substrates. In a similar fashion, enzyme inhibitor, in a similar fashion, antigen antibody, as all of you are aware, antigens are very specific. The molecules to be purified is specifically adsorbed by binding substance, that is a ligand, which is immobilized on an insoluble support matrix. The ligand is attached to the matrix by physical absorption or by a covalent bond. By physical absorption or by covalent bond. Then Then the last technique which is mentioned in your syllabus, that is a crystallization. Crystallization technique. This is the usually the last stage in the some of the fermentation products which we obtain in the form of solid, in the form of powder, or in the form of solid. The last stage is the crystallization. That is, you have to remove water by any means, and the desirable fermentation product you have to obtain in a powder form, in a solid form, or in a powder form. So crystallization, it is an established method which is used in the initial recovery of organic acids, amino acids, and it is more widely used in the final purification of diverse range of the compounds. For example, here they have been mentioned in citric acid production. The filtered broth is treated with calcium hydroxide. The filtered broth is treated with calcium hydroxide so that the relatively insoluble calcium citrate will be precipitated from the solution. The calcium citrate is filtered off and treated with sulfuric acid to precipitate the calcium as the insoluble sulfate and release the citric acid. So in crystallization, it is also used in the recovery of amino acids, glutamic acids, and lysine and certain other amino acids. Lysine and certain other amino acids. आता आपण काय केलेलं आहे आपला रिकव्हरी जो काय टॉपिक आहे त्याच्या ज्या काय रिकव्हरी टेक्निक्स आहेत सो वी हॅव कम्प्लिटेड द टेक्निक्स विच आर मेन्शन इन अवर सिलेबस फॉर recovery technique. That is, first we have seen the filtration, then we have seen centrifugation, then we have seen what we can say this flocculation. Then next to flocculation, we have seen solvent extraction or liquid extraction. Then we have seen recovery of the solvent, that is the distillation. Then we have seen precipitation. Then we have seen various chromatographic technique. And lastly, we have seen crystallization. So in the beginning lecture, as I have told you people, that is a recovery of the product. Recovery of the product is a very difficult. So what happens? We have not seen recovery of a certain or specific fermentation. So in general, we took the review of what you can say this purification operations, recovery operations, or product separation. Product separation. So what happens in case of the product separation? Your product must meet with the standards which are laid down by standards which are put down by standards which are laid down by put forth by some of the regulatory agencies, and as per those regulatory authorities or as per those regulatory agencies, again the what you can say that again the this fermentation product should fulfill आता काय करायला पाहिजे त्यानं काय फुलफिल करायला पाहिजे क्वालिटी कंट्रोलचे जे काय ॲस्पेक्ट्स असतात क्वालिटी कंट्रोलचे जे काय ॲस्पेक्ट्स असतात ते क्वालिटी कंट्रोलचे ॲस्पेक्ट्स त्या डिझायरेबल फर्मेंटेशन प्रॉडक्टनं फुलफिल केले पाहिजेत किंवा मीट केले पाहिजेत आणि मग ते कोणकोणते क्वालिटी कंट्रोलचे ॲस्पेक्ट्स आहेत फॉर एक्झाम्पल आपल्या सिलेबस मध्ये काय सांगितलेलं आहे क्वालिटी कंट्रोल इन फर्मेंटेशन इंडस्ट्री ऑफ टेस्टिंग ऑफ काय करायचं the recovered product you have to test it for sterility testing, pyrogen testing, carcinogen testing, toxicity testing and allergen testing किंवा allergens टेस्ट करायचे आपणाला तर ते कशा करायच्या हे आपण आता नेक्स्ट टाइम पाहणार आहोत आज किती जण आहात फक्त 21 विद्यार्थी दिसतात बाकीचे कुठे गेले येस सिद्धी शिंदे नाझनीन इनामदार what happened about other students
येस सर
कुठे गेले नाझनीन बाकीचे
आहे सर
आहेत म्हणजे आता तर इथं 22-23च दिसतात तुमची एक्झामची डेट लागली आहे माहिती आहे ना येस. आता आपणाला माझ्याकडे जो काही सिलेबस असाइन केलेला होता त्यातला आता फक्त 2-3 टेस्ट राहिलेले आहेत. एक स्टर्लिटी टेस्टिंग, दुसरं पायरोजन टेस्टिंग, तिसरं टॉक्सिसिटी टेस्टिंग, चौथी आहे ॲलर्जी टेस्टिंग. एक स्टर्लिटी टेस्टिंग, पायरोजन टेस्टिंग, टॉक्सिसिटी टेस्टिंग अँड व्हॉट यू कॅन से ॲलर्जी टेस्टिंग. तर त्याचं टेस्टिंग कसं करायचं ते आपण पाहणार आहोत. त्याचं टेस्टिंग कसं करायचं आहे ते पाहणार आहोत. हॅलो.